So let us now try to simplify the square root of 72. Once again, we can get our perfect squares by taking the counting numbers squared. So 1 squared is 1. That's not going to be that useful for us. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. That's about as far as we need to go. We could keep going, of course. So what we'll try to do is factor out perfect squares out of the number 72. We try to divide 72 by 4 first. Now that doesn't work. Can we divide 72 by 9 and get a nice even number? Yes, we can. 72 is divisible by 9. So we can factor 9 out of 72. And 9 times what is 72? 9 times 8. Now looking at the number 8, we ask ourselves, can we factor another perfect square out of the number 8? Yes, we can. 4. So we can break up the number 8. We can break that up into 4 times 2. Now that we're just left with the number 2, there are no perfect squares we can factor out of that, so we just need to take the radical down to each individual term. So the square root of 9 times the square root of 4 times the square root of 2. The square root of 9, why that's 3. The square root of 4, that's 2. And the square root of 2, that just remains as the square root of 2. It's an irrational number. We have 3 times 2 out front, we remultiply them, and we have 6 square roots of 2. Okay? Alternatively, we could have realized that the largest perfect square we can factor out of 72 is 36. So we can break up the square root of 72. We can break that up as the square root of 36 times 2. And then we just need to take the square root of each. So we'll have the square root of 36 times the square root of 2. The square root of 36 is just 6. And once again, the square root of 2 is irrational. We'll leave it as the square root of 2. Either way, we get the same answer. But as you can see, if we factor out the largest perfect square, in this case 36, initially, we save us a lot of time.